Have you ever investigated whether we are truly the only ones in the universe? On the other hand, are you accepting that there's more to our existence than meets the eye? Instead of what we see, imagine what would occur if the James Webb Telescope finally demonstrates that we live in a black hole. Such a discovery has the potential to alter everything. As we find out more about this revolutionary discovery, it will raise questions in your mind, challenging everything you believe to know about the universe. So what exactly are black holes? They look like something from a terrifying nightmare. You may have seen them in science fiction films. But in actuality, they're truly terrifying. Researchers claim that black holes exist because space contains massive amounts of material packed into an extremely small area, like a star, usually a lot bigger than the sun, packed into a New York-sized sphere. The gravitational pull in New York City would be so strong that not even light can escape it. Researchers have long been fascinated by black holes, spending time studying space objects that are so enormous and dense that they can trap light. The most famous theories about black holes were predicted by Einstein's theory of general relativity. Basically, when a large star collapses, a dense core is left behind. If this core has multiple masses, many times that of the sun, gravitation takes control entirely, resulting in the formation of a black hole. Detecting black holes is no simple endeavor because they do not produce light. However, researchers have discovered methods to observe their behavior to deduce their presence. For example, they observe black holes' effects on nearby objects. If a black hole moves through interstellar matter, it will pull that matter toward it through a procedure known as accretion. Additionally, when a star approaches a black hole too closely, it can be torn apart, emitting X-rays as it disintegrates. Consequently, black holes also possess a significant impact on their surroundings. They can consume nearby stars, emit powerful radiation, and even influence the formation of new stars, sometimes varying the speed of this process. But where exactly do black holes originate? Imagine stars that were once enormous and powerful meeting their violent end in an extraordinary occurrence known as a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are formed from massive stars that have reached the end of their life cycle in a supernova explosion. Smaller stars, when they die, become what we call neutron stars, extremely dense, but not dense enough to hold light. However, if a star is several times as heavy as the sun, it collapses under the weight of its own gravitational force, creating a black hole. When these collapses occur, something strange happens near their surfaces. Time itself starts acting differently. From the perspective of a far-off observer, time seems to slow down near the event horizon, the final destination for anything that falls into a black hole. It's as if the star's clock ticks at a different speed than our own. Occasionally, two smaller black holes collide, merging to form a much larger and more terrifying black hole. If a neutron star interacts with a black hole, they produce a huge cosmic phenomenon beyond comprehension. Researchers have been attempting to comprehend the immense size of black holes for decades. These mysterious entities come in two main sizes, large and small. Despite the fact that small is a relative term when it comes to black holes, stellar mass black holes, formed from the remnants of giant stars, can range from 10 to 100 times the size of the sun. There may be as many as 10 million to a billion of them in the Milky Way alone. But wait, there's something even more extraordinary: supermassive black holes. These behemoths are at the extreme end of the spectrum, with masses in the millions or even billions of times that of the sun. They inhabit areas many times larger than the sun and reside at the heart of huge galaxies, including the Milky Way. It's similar to a massive dead space, snatching everything that comes too close. Stephen Hawking, a well-known physicist, conducted extensive research on black holes. His theories were always fascinating, yet some of them could not be proven due to a lack of necessary equipment. But there's hope. A single scientific discovery offers the potential to validate these theories. That instrument is the James Webb Space Telescope, JWST. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a testament to human ingenuity. We've launched other spacecraft and telescopes before, and they've performed admirably, but this powerhouse is truly extraordinary. The JWST makes the Hubble Space Telescope, which has served us for decades, seem like a mere speck in comparison. The cost of this cosmic wonder? A staggering $10 billion. Yes, you heard that right. Enough zeros to leave you stunned. This scientific marvel was brought to life through the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency, with invaluable input from over 300 colleges and universities. But such an ambitious endeavor comes with significant risks. The JWST is exploring uncharted territory, pushing the limits of what we know and taking us to places we've only ever fantasized about. After its recent launch, NASA announced that the telescope has enough fuel to last more than twice as long as its initial mission. Since its inception, the JWST has achieved some incredible feats. After traveling over 1 million miles, it reached its sun-circle orbit, where it will remain permanently. During its journey, the telescope successfully deployed its gigantic 5-layer sun shield and primary mirror, both of which had to be folded to fit inside the launch vehicle. Now that NASA has improved and calibrated it, the telescope is nearly ready for full operation. One of the most incredible aspects of JWST's mission was when NASA announced that the first images it captured were of a star known as HD 8446, resulting in a mosaic of 18 scattered stars with bright spots. Light was absorbed by the 18 segments of the primary mirror. Later, NASA released a stunning new HD image of HD 8446, where the 18 unfocused copies of the star were arranged into a deliberate hexagonal pattern. Once the observatory successfully aligns the individual sections of the primary mirror, it will begin the process of image stacking, combining the 18 images into one clear view. Thanks to its state-of-the-art technology, the JWST will help scientists study the universe's earliest stages, following the Big Bang. It will focus on what happened after the first stars formed during the so-called epoch of reionization, when neutral hydrogen was reionized, gaining an electric charge again due to radiation from these initial stars. This event dates back billions of years, something only a powerful telescope like the JWST can observe. The telescope will also aid in discovering exoplanets, planets outside our solar system that are incredibly difficult to detect due to their interaction with their host stars. Its powerful sensors will have the ability to observe these planets in greater detail, sometimes even imaging their atmospheres. Understanding the conditions of these planets may assist scientists in determining whether some of them are habitable. In addition to studying the formation of planets, scientists will use the JWST to analyze galaxies, seeking to understand how they are organized on a massive scale. This discovery opens up new questions that could reshape our understanding of both black holes and the origins of life. Typically, the intense radiation near a black hole would break apart complex molecules like pHs. Yet against all odds, these molecules not only survive, they seem to thrive in this harsh environment. Could black holes somehow contribute to the creation or preservation of the very building blocks of life? Garcia-Bernat's team found that the PAHs near black holes exhibit unusual chemical signatures, suggesting they might be more resilient than scientists previously thought. Their ability to persist under extreme radiation challenges our current knowledge of molecular chemistry in space. Even more astonishing is the possibility that these molecules, carried by cosmic winds or jets emitted by black holes, might spread throughout galaxies, potentially seeding planets with the essential ingredients for life. Imagine this. Black holes, often viewed as cosmic destroyers, could also play a role in the creation and distribution of life's building blocks. This paradox adds another layer to the already complex nature of black holes. If PAHs can survive and travel through space, could they have reached Earth billions of years ago, kickstarting life as we know it? This theory, known as panspermia, suggests that life's ingredients might not be unique to Earth. They could be scattered across the universe, waiting for the right conditions to spark life. But the implications go even further. If PAHs are abundant near black holes, could similar molecules exist in other extreme environments, such as the atmospheres of distant exoplanets or the icy moons orbiting gas giants in our solar system? The James Webb Space Telescope's advanced infrared sensors are perfectly suited to search for these molecular fingerprints. By analyzing the light passing through exoplanet atmospheres, JWST can identify specific chemical compounds, offering clues about the planet's potential habitability. For example, detecting water vapor, methane, and carbon dioxide could indicate that an exoplanet has conditions suitable for life. If JWST also identifies PAHs or other organic molecules, it would strengthen the argument that the ingredients for life are widespread throughout the cosmos. Some scientists even speculate that, within the next few decades, JWST could provide evidence of alien life, whether through detecting biosignatures in exoplanet atmospheres or uncovering unexpected chemical patterns that hint at biological processes. At the same time, the telescope's observations are shedding light on the role black holes play in galaxy evolution. The gravitational pull of a supermassive black hole can influence the movement of stars and gas within its host galaxy, shaping its structure over billions of years. Yet, black holes don't just consume matter. They can also release powerful jets of energy that spread across thousands of light years, impacting star formation in distant regions of space. This dual nature, both destructive and creative, raises profound questions about the universe's fundamental forces. Could black holes, despite their terrifying reputation, be essential to the development of galaxies and, by extension, life itself? The JWST is helping scientists unravel this cosmic puzzle by capturing detailed images of galaxies at different stages of their evolution, providing a window into the processes that have shaped the universe since its earliest days. But perhaps the most mind-bending possibility of all is the idea that we might be living inside a black hole. Some physicists propose that our universe could be the interior of a massive black hole that formed in a higher dimensional space. According to this theory, the event horizon of our black hole universe would be the boundary separating us from the outside world, just as the event horizon of a black hole in our universe marks the point of no return. While this idea might sound like science fiction, it's grounded in real physics. The equations that describe black holes share striking similarities with the equations that describe the expansion of our universe. If this theory is correct, it could explain some of the biggest mysteries in cosmology, including the nature of dark energy, the force driving the universe's accelerated expansion. So what's next? As the JWST continues its mission, scientists hope to gather more data that could confirm or challenge these groundbreaking theories. With its unparalleled ability to peer into the depths of space and time, the telescope might soon reveal evidence that reshapes our understanding of the universe and our place within it. And if black holes truly play a role in spreading the building blocks of life, then perhaps the universe is more connected and more alive than we ever imagined. Black holes altered the pause fundamentals, changing them into bigger, electrically neutral versions of themselves. The less significant, electrically charged pHs vanished into the gloom, almost as if they were swallowed whole by the empty space itself. But wait, there's a glimmer of hope, or perhaps not. The actual question is not simply whether or not we are alive, but whether or not we actually exist. Everything around us is made possible by forces that appear to conform to the hypothesis that we are not simply residing within a black hole, but rather within its event horizon, a line that separates our universe from it. It's possible that the unidentified everything is connected within a black hole. The James Webb Space Telescope is out there right now, searching for answers to these mysteries. Keep an eye out. Perhaps it will cause us all to reconsider everything we believe to be true. The actual world might be much more twisted than we ever realized. The mystery of black holes in the dazzling cosmos. Few topics in cosmology generate as much mystery and fascination as black holes. These enormous beings, with their ability to consume and warp space-time, and everything in their vicinity have long been the focus of both scientific research and popular imagination. The most recent claim, made by Michio Kaku, a well-known physicist, suggests that we have finally uncovered the contents of black holes, adding even more intrigue to the debate. But what exactly does this bold statement mean? Has science finally unlocked the secrets of what lies beyond the event horizon of a black hole? Understanding black holes requires us to step back and explore their nature and significance in light of recent discoveries. What is a black hole? A black hole is a region of space-time where gravity is so strong that nothing, not even light, can escape. This phenomenon occurs when a massive star collapses under its own gravity after running out of nuclear fuel. When this happens, the star's core contracts, and if the mass is great enough, it forms a singularity, a point of infinite density where the laws of physics, as we know them, disintegrate. This singularity is surrounded by the event horizon, the boundary beyond which nothing can escape, not even light. For decades, black holes were purely theoretical. The concept first emerged from Albert Einstein's general theory of relativity, but it wasn't until the 1960s and 1970s that scientists like Roger Penrose, John Wheeler, and Stephen Hawking developed the mathematical framework that introduced black holes into the realm of accepted science. Even with this theoretical understanding, what lies within black holes remains a mystery. Beyond the event horizon of a black hole is a point of no return. Once something crosses this boundary, it is inevitably drawn toward the singularity, where it is crushed to infinite density. Due to the nature of black holes, we cannot directly observe what lies beyond the event horizon. Light itself cannot escape. Scientists long believed that black holes were cosmic places where all information about the objects that fell into them was permanently lost. This concept became known as the information paradox, which arose from Stephen Hawking's work in the 1970s. Hawking suggested that black holes could slowly evaporate due to what is now known as Hawking radiation, a quantum effect that causes black holes to lose mass gradually over time. If this radiation destroyed all information about what had fallen into the black hole, it would violate a fundamental principle of quantum mechanics, unitarity, which states that information must be preserved. As research into black holes advances, new questions and theories emerge, challenging our understanding of these cosmic phenomena. Black holes as gateways to other realities. One particularly intriguing idea is that black holes could serve as gateways to other parts of the universe, or even other dimensions. This concept is rooted in wormhole theory, which suggests that black holes might be tunnels connecting distant regions of space-time. While wormholes haven't been proven to exist, they are frequently depicted in science fiction as shortcuts through the universe. If such exotic structures were real, they could potentially provide a way to bypass vast cosmic distances, offering us a glimpse into an entirely different reality. Do we inhabit a black hole? Black holes have also sparked discussions about the very nature of our existence. Could it be possible that the universe we perceive is merely a simulation, a construct within the event horizon of a black hole? Some scientists and philosophers suggest that the nature of our existence may be linked to the enigmatic forces governing black holes. These inquiries require us to reassess the fundamental principles of physics and the role consciousness plays in shaping our perception of the universe. Could we be living inside a black hole, surrounded by distorted space-time that alters our very perception of reality? The fascinating nature of time. Black holes might also offer insights into the nature of time itself. Time dilation, a phenomenon where time appears to slow down near the event horizon, occurs due to the intense gravitational field of a black hole. To an observer further away, time near the black hole would appear to move more slowly. This phenomenon may hold the key to understanding the nature of time and whether it is a constant or something that can be manipulated by cosmic forces. Future research into black holes may lead to new theories or technologies that could enable us to control time or even travel into the past. The ultimate cosmic mystery. In the end, black holes remain one of the greatest enigmas of the universe. The James Webb Space Telescope, with its advanced technology, might play a crucial role in uncovering their deepest secrets. As we continue to explore the farthest reaches of space, the mysteries of black holes will continue to captivate our imaginations and drive scientific discovery.